Okay, so we're on, this is actually problem number 3 from the homework. I think it's a good place to start. And from the 7.1 homework, let's just review what a probability is. A probability is a ratio that studies how likely it is that a certain event can happen. So what's an event? An event, so before we even talk about probability, what's an event? An event is a special sort of set of outcomes that we've singled out to study. They all share a certain property. Okay, so in this case, the event would be rolling at most 5. Okay, at most 5 would be our event. Okay, are there lots of different outcomes that can give you that event? Sure. There's if you get like a roll of 4, that's part of the event. If you roll a 3, that's part of the event, etc. So an event is a collection of outcomes. Okay, so this is the particular event that we're studying right now. Now, what's a probability? So the probability of an event is equal to the number of ways the event can occur, number of ways or outcomes leading to the event, or let's say number of outcomes in the event, because event's really a set of outcomes, divided by the number of ways or outcomes in total for any event, so we'll just call it in total. Now, the number of outcomes in total, that's also called the size of what's called the sample space. The sample space is the set of all outcomes. Okay. Now, in this particular problem, we're rolling a die one time. So if we roll a die one time, that's our experiment, and it generates a sample space. The sample space is the set of all outcomes. So the sample space for this experiment would be what? What can you get if you roll a die one time? You can get a 1, a 2, a 3, a 4, a 5, or a 6, right? So that's my sample space. It has 6 elements. So that means I know the denominator of my probability fraction is going to be 6. There's 6 elements or 6 outcomes in my sample space. Now, what about the numerator? The numerator of my probability is going to be the number of ways that the event can occur. So the event in this case is getting at most 5. That's the special sort of, we've isolated or singled out certain outcomes and called them a specific event. In this case, the outcome is giving you at most 5. So at most 5 means 1, 2, 3, 4, or 5. Okay, so of these elements in the sample space, which of them are also in the event? Is a 1 at most 5? Yeah, at most 5 means 5 or smaller. Okay, that means 5 or less. So is a 1 5 or less? Yes, it is. How about a 2? Yes, a 3, a 4, even a 5 is 5 or less. Okay, only the 6 is not. So how many outcomes are there in the event of 5 or less? Or another way to say that is at most 5. How many outcomes are in that event? 1, 2, 3, 4. There's 5 of them. 1, 2, 3, 4, 5 of them. So that's the numerator of my probability fraction, 5 over 6. And if we divide 5 over 6 and then round to 2 decimal places, we'll get this result. Okay? All right, cool. Okay, so this is actually problem number 4, which is similar to 3, so it makes a good comparison. So this is problem number 4 in the homework. And so they want to know the probability of rolling. So first of all, we have a fair die, and we're rolling the die one time. That's our experiment. That's what we're doing. Okay, what are the outcomes? What's the sample space? The sample space is the collection of all possible outcomes. What can you get if you roll a die one time? You can get a 1, a 2, a 3, a 4, a 5, or a 6. That's it. Okay, and they're all equally likely outcomes. Okay, so that's our sample space. Now, of these elements in the sample space, which ones are in the event that they're asking us about? What's the event they're asking us about? Rolling a number that is at least 5. That's what we want to happen, so that's our event. Now, the event is going to consist of multiple different outcomes. So when we say at least 5, what does that mean? At least 5 means 5 or more. Now, since the biggest we can get is 6 here, we could also think of this as 5 or 6. So which of these outcomes would be a 5 or a 6? And the answer is the 5. and the 6. Okay, those are so my event consists of these two particular outcomes from within the sample space. So now let's construct the probability fraction. Okay, so my probability of 5 or more on a fair die is going to be equal to what? Number of ways or number of outcomes in the event. What's the event? 5 or more divided by number of ways for anything. Number of ways for all outcomes. Or another way to say that is the sample space size. The number of events in the sample space. Or the size of the sample space. So what's the size of the sample space? 1, 2, 3, 4, 5, 6 possible outcomes in the sample space. What's the size of the event? How many of those outcomes give rise to the event? And the answer is 2. Okay? And 2 over 6 is 0.33 if you round it to 2 decimal places. Okay? And that's it. It's a pretty easy concept. It's a very useful concept. All right, let's try. Let's see, that was number 4. I guess let's try 5. Okay, this is actually problem number 5. Whoops, hello. Trying to bring up the pen here so I can write on my screen. There we go. Computer's a little slow today. All right, so this is problem number 5. So what's the event that we're trying to single out? Well, first of all, what is the experiment? Okay, the experiment is pulling socks out of a drawer. Okay, so that's my experiment. So what's the sample space? The sample space is, if you wanted to draw it, it would look like this. I mean, it's a little bit of work to write out the sample space here. The sample space is all outcomes. So let's see, I've got 14 white socks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my 14 white socks. Okay, then I've got 3 black socks. I'll have to use, I guess, B. Black and brown both start with the same letter, so I'll use B for black. So I've got black, 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 3 black socks. And then for brown, I guess I'll use R for brown, because second letter. So I've got, the rest are brown. So far, how many have I accounted for? I've accounted for 14 and 3 makes 17, right? So there's how many left over? Another 12, right? That are brown. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's count. We got 12 and 3 is 15, right? And 14 makes 29 total socks. So this is my sample space. Okay? Now, which of these are in the event that we're looking for? Well, what's the event? The event is the special set of outcomes that are being singled out for analysis. And so the event we're looking for is that if we randomly select a sock from the drawer, that it will be black. Okay, I think they meant will instead of sill. It's a misspelling. Sorry about that. Okay, so we're going to pull out a black sock from the drawer. Okay, so of these 29 outcomes, which ones are in the event? These 3. Okay, so if we follow the definition of what a probability is, probability of getting a black sock out of this particular drawer is going to be the number of outcomes in the event, but divided by the number of outcomes in the sample space, meaning the number of outcomes in total. Okay, so what is the size of the sample space? Well, they told us, 29. And we see it from the picture. Okay, how many of these are the outcomes? How many of these outcomes, of these 29 outcomes, are in the event? Black sock. And the answer is 3 of them. And we're done. Okay, 3 over 29 is, I'm getting 0.103. If you round 0.103, 10345, like that. But to 2 decimal places, just be 0.10. That's where they're getting this from. Okay, and that's it. Same concept. Cool. All right, that was number 5. I'm just trying to pick one students had some difficulty with. Let's try number 8 next. Okay, so on this particular problem, this is number 8. What is the event we're looking for? The event is, well, what's the sample space? The sample space is all the cards in the deck. Okay, what about the event we're looking for? What's the event? What's the specialized set of outcomes that we're trying to study? And the answer is a card whose face value is 5. All right, so let's bring up a picture of the deck of cards. So here's a picture of a deck of cards. And so notice there's 52 possible outcomes if you count all the cards. And which ones have a face value of 5? Okay, well, it's going to be, in fact, let me go ahead and just bring up the pen system here so I can draw on the screen if it's going to let me. Hang on. Okay, and so of these 52 outcomes, which ones are in the event that, I guess what's a good color here? I guess we'll go with like a blue. Which ones are in the event face value of 5? And the answer is this card, this card, this card, and this card. They all have a face value of 5. So therefore, the probability of getting a 5 is going to be the number of outcomes in the event. And what's the event? The event is getting a 5, okay? Divided by the number of outcomes in the entire sample space. What's the sample space? I'm going to write SS for sample space. What's the sample space? It's the set of all outcomes. So how many total outcomes are there? 13 in this row, 13, 13, and there's 13 possible cards in each row, so you've got 52 total. How many of those 52 outcomes are in the event that we get a 5? And the answer is just these 4 right here. Okay? And 4 out of 52, if you divide it, is going to be, let's see, 4 over 52, bada boom. I'm getting 0.077. Okay? Approximately 0.077. Sorry about that. And so rounding to 2 decimal places is about 0.08, which is what you see over here. Okay? Pretty easy. All right, let's see. So that was the cards. That was number 8 from the homework. I guess let's skip around. Let's skip to 11, where we work with the data table. Okay? Okay, so here we are on number 11. And so what is the sample space? The sample space is all these male students. Some of them took test A, some of them got an A, some got a B, and some got a C. Okay, females, same idea. Some got A, some got B, some got C. So all of these outcomes together is my sample space. So how many total outcomes? What's the size of the sample space? I'm going to use SS for sample space. Okay, size of sample space. That means the total number of all outcomes, not just the special ones we're looking at, but all outcomes. That means any person getting any grade on the test. And the answer is I just add them up. Okay, 8 and 7 is what? 15 plus 13 is what? 28. So you got 28 in the first row, and then how about the second row? I've got 15 and 12 is 27, right? Let's see, 15, 12, yep, and then I got 15 and 13 is 28, and if I add those up, I get what? So it's going to be 55, right? Okay, so this is the size of my sample space, total number of outcomes. Now, of those outcomes, which ones give me the event that we're being asked about? What's the event that we're being asked about? The student was female. The thing we're trying to find the probability of is the event that we're being asked about. So the event is female. I'll just write FEM for female. I'll just write the whole word. Okay. Now, so what's the probability of picking a female at random from the class? Okay, it's the number of ways or number of outcomes in the event that we have a female divided by the number of outcomes in the entire sample space. What do I mean by the entire sample space? That means all the outcomes together. Okay? So, we already know how many outcomes there are in the whole sample space, 55. How many of them give me a female? Well, this many. How much is that? If you add that up, that's 27 ways, right? 11 and 4 is 15, plus 12 is 27. So the probability of drawing a person at random and having it be a female would be 27 out of 55, which if I do that on my calculator, I'm getting 0.491, okay? Approximately 0.491, which to 2 decimal places should be 0.49. Okay, and there we go. Easy peasy, right? So that was 11. Let's do one more. Let's try 13. Okay, this is problem number 13. Let me go ahead and bring up the screen sketch. Okay, so we're on number 13. So let's identify the sample space. So the sample space is the set of all possible outcomes. And here we have 12 people who were both male and had no credit cards. Another 17 were male and had one credit card, and another 20 were male and had two or more credit cards, etc. Okay? These are the different outcomes in the sample space. So what's the total size of the sample space? The total size of the sample space is the set of all outcomes, number of all outcomes. And we can just add them up. Okay, I've got 12 and 17 is what? 29 plus 20. I've got 49 in this row. Right? 12 and 17, 22, 29, 49. In the second row, I've got 10 and 6 is 16, plus 20 is 36. If I add those up, 49 and 36, I'm going to get what? 85? So that's the size of my sample space. Number of all outcomes is 85. 85 possible outcomes. Now, the next question is, of these 85 outcomes, which ones are in the event that we're being asked about? So what's the event? What's the special sort of singled out different outcomes? And the answer is at least one credit card. So at least one means either one or higher. Now, in the case of the way the data is divided up in this problem, that means either one credit card or the two or more. That's how they kind of broke down the number of credit cards, the data in this problem. So these guys are in the event of one or higher because they have one card. These guys are in the event of one or higher because they have two or more cards. So how many ways is that? Well, let's see. 17 and 20 is what? Well, actually, let's just do it this way. 20 and 20 is 40, and 10 is 50, and another 17 would be 67, right? So there's number of ways for this to happen would be 67 ways. So the number of outcomes in the event. And what's the event again? The event is one or more cards. Okay, at least one card is going to be, we said 20, 40, 50, 67 possible outcomes. Okay, and what's the event? The event is one or more cards. That's my event. Okay, so now let's form the probability. And as we know, the probability is a ratio. So the probability of one or more cards is a ratio of number of outcomes in the event divided by number of outcomes in the total sample space, meaning all outcomes together. And so we know the number of outcomes in the sample space we said was 85. The number of outcomes in my event is 67. So let's see. So I'm getting 67 over 85. I'm getting 0.788. I'm putting approximate because we're rounding off. The decimal actually goes forever. And so that's now to two decimal places. Let's see, they want me to round to two decimal places. That'd be about 0.79 to two decimal places. And there we go. Okay, so it's the same concept over and over again. All right.